name is Sylwia Wojno, and I'm a fourth-year PhD student from Chalmers University of Technology. Today I will try to briefly talk about phase transitions of cellulose nanocrystal suspensions and what they can be useful for. Science is aesthetic when it is aligned with nature. Cellulose nanocrystals, under special conditions, can be aligned differently, which makes them optically active materials that exhibit colorful properties or not. So, what is the reason for this opposite behavior? And can we somehow control it? Starting from the beginning, cellulose fibrils have two parts: amorphous regions and highly ordered crystalline regions. And from them, the cellulose nanocrystals can be extracted. They are highly ordered, and that's why they can interact with light. And actually, this interaction with light is very interesting. Rod-like shaped particles, like CNCs, are birefringent. That means that they refract light in a different way, depending on the angle and their phase. And that's why they can show different colorful palettes. But what is the phase transition? At certain temperatures, substances change their state. They can go, for instance, from solid to a liquid or from liquid to a gas, but it has some consequences. And similar analogies for CNCs. They don't change their physical state, but at different conditions, that is temperature, extraction method, or use chemicals, they can be aligned differently. For instance, they can self-assemble with increasing concentration to a liquid crystalline state. And actually in this state, in this way, they show all this colorful behavior. But if we add an extra amount of sulfuric acid, the route of phases will be changed, and particles, instead of self-assembling, will aggregate. In this way, in this system, they don't show colors anymore, but at the same time, the viscosity of obtained material will increase. So, why is the phase transition important? Depending on the path chosen during the chemical modification, we get CNCs which are trapped at different phase transitions. And this will result on the final properties that can be considered later on by the industry. Okay, so now we know CNCs are birefringent materials, and depending on many factors, they go to different phase transitions. But how does it look in the practice? And if and how actually can we control this phase transition process? We need CNCs, which can be extracted from natural resources like trees, sulfuric acid, some chemical bases with different ions like lithium, sodium, or potassium. Everything needs to be mixed and stirred, and as a result, we obtain cellulose nanocrystal suspensions which have different behavior. But how can we check their actual properties that can be later on considered by the industry? We need proper and precise tools to investigate their optical and viscous behavior to find these possible applications. And for that, with help comes rheology. Rheology is the study of materials flow behavior under applied deformation forces. The fact is, rheology plays an essential role when it comes to formulating everything, from food to cosmetics, inks, or coatings. It impacts all stages of materials usage in the production, transportation, or even product performance. So to investigate our prepared CNC suspensions, we need an instrument called the rheometer. We need to place our prepared material, the source of light, camera to record visual changes in the microstructure, and of course computer to process all obtained results. By playing with molecules and sulfate content, we get different outcomes. Those systems which show colorful behavior are called self-assembling. So if we want to get a specific color, we need to pick up a proper ion. But too high amount of sulfuric acid will lead to color fading, even if we add exactly the same ions to the CNC surface. And this is due to the fact that these systems have strong attractive forces, which will lead to the aggregation. And at the same time, the colors will be faded and they will increase the viscosity of obtained material. We all are attracted to colors, aren't we? We often use colors to communicate and recognize what we like and don't. And in CNCs, Color is a result of self-assembling particles in the system. By playing with molecules and sulfate content, we get different outcome. And this knowledge can be used by the industry for designing new potential applications. So if we want to get a specific color or not, and specific viscosity, we need to consider at least several factors. Those systems which show colorful behavior, they act like liquid crystals. And color is a result of self-assembling particles. In turn, the lack of color is due to strong attractive forces which lead to color fading, material will become opaque, and at the same time viscosity will increase. And both these features can find its usage in the potential applications. For instance, aligned CNCs, due to their birefusion properties, can be used as energy storage devices. On the other hand, faded aggregated CNCs can be used as rheological modifiers to increase viscosity in food, cosmetics, and some other products. That's all from my side. Thank you all for listening, and also for this opportunity that I could be here and shortly present my research.